This video is going to have a look at developing linear equations from a word problem that involve more than one unknown variable. So by the end of the video, you'll be able to use a word description that it's given to you in a question to develop and solve a linear equation. When you are developing linear equations that have two or more unknown variables, what you want to do is express the unknown variables in terms of the same pronumeral, and then create a linear equation using that one pronumeral or that one variable. So step one is going to be to define the variables in the question, and you're going to do that using the same letter. Step two is write an equation using those variables that you have defined in step one. Step two will be to rearrange and solve. And then step four is to go back and make sure that you have answered the question. You may need to find the values of more than one unknown from the original question. So you need to go back and work out what those other unknowns are that don't directly relate to the variable that you have found. So let's have a look at an example to see how we can apply these steps into practice. So in example one, Georgina is counting the number of insects and spiders she can find in her back garden. All insects have 6 legs, and all spiders have 8 legs. In total, Georgina finds 43 bugs with a total of 290 legs. The question is asking us to form a linear equation to determine exactly how many insects and spiders that Georgina found. So applying our 4 steps, the first step is to define the variables in the question. And the question is asking us to find out how many insects and how many spiders that Georgina found in the back garden. So we're going to let the number of spiders equal S. So our variable that we are using throughout the question is going to be S, which is the number of spiders. But the question also asks us to find out how many insects were in the backyard in addition to the spiders. So we're going to let the number of insects equal 43 minus S. So we know there was 43 bugs in total because that is given to us in the question. So if S represents the number of spiders, the number of insects is going to be the difference between the number of spiders and 43. So 43 minus S. So we have been able to define our variables using the same letter. So S for spiders. Spiders is S, number of insects is 43 minus S. Now I can use those two terms to now come up with a linear equation for step 2. So based on the other information in the question, I know that insects have 6 legs and spiders have 8 legs. So I'm going to develop an equation for the number of legs in total. So the number of legs in total for spiders is going to be 8. So it's going to be 8 times S. And for insects, it's going to be 6. So it's going to be 6 times 43 minus S. And that's going to equal to a total of 290 legs. So that is the equation that I now need to go ahead and rearrange and solve to complete step 3. So before I rearrange, I'm going to go ahead and simplify that equation by expanding my brackets. So 8S plus 6 times 43 minus 6 times S is going to equal 290. So 8S equals 258 minus 6S. So simplifying that, I'm left with 2S plus 258 equals 290. So now I can go ahead and rearrange. Applying my reverse bitmass order, I'm going to remove the plus 258 from the left-hand side, and I do that by subtracting 258 from both sides. So 2S is going to equal 32. Divide by 2 on both sides to get S by itself. So S is going to equal to 16. So the number of spiders I have in the garden is 16. So now I've got to go back and make sure that I have answered the question. And the original question was asking how many insects and spiders. Well, I know that I've got 16 spiders, so I need to go ahead and calculate the number of insects. So the number of insects is going to be 43 minus 16, which is equal to 27. So I know that Georgina found 16 spiders and 27 insects in her garden. And if I worked it out, that would add up to a total of 290 legs. So let's have a look at a second example, which is question 7 from your textbook. One week, Jordan bought a bag of his favorite fruit and nut mix at the local market. The next week, he saw the bag was on sale for 20% off the previously marked price. Jordan purchased 2 more bags at the reduced price. In total, Jordan spent $20.54 for the 3 bags of nuts. We want to calculate the original price of the bag of fruit and nut mix. So going through the 4 steps. Step 1, to define the variables in the question. And we know that he bought a bag of mix and he bought another 2 bags of mix for a reduced price of 20%. So we're going to let the price of the bag, the original price of the bag equal P, and the discounted price of the bag is going to be 0.8p. So 0.8p comes from our 20% off. So if you have 20% off, you're left with 80% of the original price that you are paying, so 0.8p. So next step is to write an equation. So we know he bought 1 bag at the original price and 2 bags at the discounted price. So that is going to be P plus 2 times 0.8p. And in total, he paid $20.54. So P plus 2 times 0.8p equals 20.54. So that's the equation that we have developed based on the information in the question. Now we can go ahead and apply step 3 to rearrange and solve. So first I'm going to simplify it. 2 times 0.8 is 1.6. So P plus 1.6p equals 20.54. So adding my p's together, 1 plus 1.6 is 2.6. So 2.6p is equal to 20.54. To find p by itself, I need to divide both sides by 2.6. So my p value is going to be 7.9. So now that I've got my p value, I can go ahead and answer the question. Now the question was only asking me for the original price of the bag of fruit and nut mix, which was represented by P in our equation, and we know that is $7.90. So I don't need to do any additional calculations. I can go ahead and answer the question. The original price of the bag of fruit and nuts mix was $7.90. So there are a couple of examples of how we can create a linear equation when we have a word question that has more than one unknown, and we do that by using the same variable and then going ahead and writing an equation, rearranging and solving.